make you guys uncomfortable. Okay. Anyone, any questions, please? Thank you. So Mira, the question to be tested. Wait, let me check. So the homework to be yep, longitudinal shear homework 4, 7, 8, and 9. Okay. Okay, 9 will also be included. But for 9, I wrote on Avenue to Learn. I will not be expecting you guys to solve. Wait, let me. I think I posted the solution. Okay, so y'all can do all these. Okay, y'all can construct. Okay, y'all can construct the element. Okay, but I don't expect you to draw mole circle at all. Okay, I do not expect y'all to draw mole circle. So solving all this not yet. Okay, so it's just getting just drawing the element. Okay, so I want you to be able to draw element. Okay, so yeah, or calculate the stresses or draw the element. Okay, so draw the element. Wait, is there? Yeah, you have to be able to construct an element like this with the associate stresses. Okay, but I'll not ask you find the principal stress. So Abigail, positive or negative shear, okay, in a shaft. Okay, so I'm gonna answer that question over there. So the question asks regarding positive or negative shear. Okay, so is it important now? I'll tell you for your term test. I'll tell you no, because as I said, I'm not asking you all to solve mole circle, but I'll quickly go over. Okay, so let's say we have a element like this. Okay, so we're going to take this element. This is what we have done today. Okay, so copy, and I'm going over here, and I'm going to paste. I'm going to paste in the image. Right. So for this case, right, we are looking at this. This is what we had today. Okay, before after the tutorial where I stopped early. Okay, so this is what we have drawn. Okay, so now if we were to draw this element, okay, in a view that you are more familiar, so it looks like this now. Okay, so we know that we have stresses this way. That is 18.35 megapascal, and then we have a compression of minus 14.948 megapascal. Now our view is Y, Z, and this is X. Okay. No. Yep. This is our X. Okay. So we're doing this way. So this is positive shear. Okay. So let me show you what is positive shear. So if this is our plane, okay, and our element, our orientation now is looking like this in 2D. Okay. So because the stresses are acting this way, the shear stress, so the other end, it will be in this direction. So this is similar to what we have over here. So the element will deform in a way that it looks like this. So this is how the element deform. Okay, so how do I visualize is I pinch this arrow. I use 2 fingers to pinch. The other one, I use the other fingers to pinch. So when I pinch it, the deformation looks like this. So for this case, this is known as positive shear. And then on negative shear, how does it look like? Okay, I want to show you what is a positive shear and what is it. So this is our negative shear. So those 2 arrows where you see, you take your thumb and another finger, you pinch the square, this is the way it's deformed. Okay, so this is what we call negative shear. So for our case, for this case over here, what you see is what? Positive shear. Okay, and this direction over here is got from the shear flow, yes or no? Or we can formulate this in terms of shear stress, which is equal to VQ over IT. Okay, so that is what we have. So in terms of torsion, okay, so if we have a torsion now, right? So Abigail will say torsion. Okay, so if we have a torsion now, right? So we are interested in element A down here. Okay, or element A should not be drawn like that. So we're interested in a certain element over here. So this is our element A, for example. So if the material, if the moment, so if I call this our transformation, right? So this is X, Y, and Z. Okay. So for this case, if our, so what we are trying to analyze is how the element were deformed, right? So the element were deformed this way, right? So now I view, let me draw a curve. Okay, so where I'm viewing now, so I view X and Z. Okay, so because of the torque in the Z direction, okay, so it will deform this way, right? So this is a shear, so this is a shear that's going to be induced. Okay, so if you were to ask me, right, this is the shear, and then if that's the case, this will act this way, and this will act this way, and this side will act this way. Again, this will be known as positive shear. Because if you see how the element deform, the element wrong color, the element will deform this way. Okay, the element will deform this way. So that is a positive shear direction. Okay, Abigail, are you okay in that before I go to the next one? So I think Abigail did not say anything, so she'll be just wondering for the positive shear drawing, if we were looking at it from the other side, will it be considered negative shear? How do we know which orientation? Roseanne, if you were to draw the other side, right, this thing has to flip. Right, this thing has to flip, right? So if I draw from the other side, okay, if you say I view it from the inside, okay, if I view it from the inside, right, so this is my Z, and then this is my Y. So the transformation changes, right? So now it looks like this now, right? And then your deformation go this way, right? So this now, if you draw it this way, then this will also be what? Positive shear. Okay, Roseanne. So it's relative to your what? To your transformation. Okay. I think I did not draw this well, so it will look this way. Okay. So why is this positive shear? Also, I'll tell you why. Because if this is your origin, the center is always the origin, and this is your Z, and this is your Y, right? The surface that I'm highlighting now is positive area, right? And the shear stress is also positive. That's why it's positive. If you look at the Z, right, the area relative to the Z is also in the positive side, and the stress is it's pointing towards positive stress also. So that's why this is positive shear configuration. Okay, Roseanne, you okay? Okay. So anyone else, please, regarding
Professor.
Yes.
From homework 9, so a lot of the questions have the round cross sections. Could you go over quickly how to take Q, the moment of area Q for a round cross section?
Wait, let me see. Homework number what?
9, the most recent one, like the pipes and the.
Okay, hold on.
Just generally how to take the Q of a circular cross sectional area.
So anyone that, but sometimes the circular cross section area is kind of useless. But sometimes it's still okay. Mustafa, is question 2 okay? If I pick question 2.
Yeah, question 2 is fine. I think that one also has Q equal
Or it can be question 3.
And
Okay.
any of them work.
Okay, so I'll pick question 3. Okay, I'll pick question 3. So I'm not going to break down the forces. Okay, I won't do that. But I'll tell you the principle. The principle is very similar to rectangle. Okay, so anyway. Right. So let's see what forces are critical. Okay, what forces are critical for us. So if I were to look this in the x z no yz plane. Okay, so if I'm going to look this in the yz plane, I'm only going to do for the shear only. Okay, so this is our yz. So if I were to look at our yz, this is what I see, or we will see. Okay, right. So you have a 600 coming down here, right? And then you will have a 2,500 over there. Then if I draw, so construct element H. Okay, so like what I always tell you guys, look at element H. Right, so this you all should be able to break down very easily, given how I taught you guys. Okay, so element K. Okay, so for this case, then I will construct my neutral axis. Right, so the 600 is going to cause a moment in the x direction, right? And the distance from here to here is 2.5, right? So we know moment about x, right, is equal to element is equal to 600 times 2.5. So 600 multiplied 2.5 is equal to 1500 Newton meter. Okay, we get that. Then we also know, right, you have a 600 coming in, so there's a reaction of 600 from the top. Okay, so that will be equal to our Vy is equal to 600. Okay, so I'm trying to look down. So we have another one, which is our Mz. So, but before we go on, we know that on element H, right, because the deformation is going this way, element H will be tensile, and element K will be what? Will be 0, right? Because it is at the centroid. For Vy, okay, for Vy, so down here, what I'm going to say to you that will not not disable those that don't attend the. I have to be careful that don't attend. It's okay. It's a class and they don't come. So for VY,